Hello calculus students and seekers of truth. In this video we will conclude our discussion of higher order derivatives with one example. So I have a function f of x equals 5x to the fourth plus 3x squared minus 8x to the third plus 5. And we want to find the first derivative, the second derivative, and the fourth derivative. So the first derivative, we're going to apply our product rules here because this is just a polynomial. So that's going to be 20x to the third plus the derivative of the second part. So that's going to be 6x minus the derivative of the third part, which is 24x squared. I almost wrote 8x there, so it's 24x squared. And then the derivative of 5 is just going to be 0. So that gives us our first derivative. To find our second derivative, we're just going to take the derivative of the first derivative. So this will be 60x squared plus the derivative of 6x is 6 minus 48x. Now, if we want to find the fourth derivative, then we need to find the third derivative. So let's just do that right now. And instead of putting 3 tick marks, which I could, but that's going to get a little bit crazy, I'm going to put f to the third with parentheses around it. The parentheses are significant because they tell me that's the derivative that I'm looking for here. So this will become 120x. The derivative of 6 is just going to be 0, and then the derivative of negative 48x is just going to be negative 48. And I can get to the final problem now. The fourth derivative is nothing more than the derivative of the third derivative, which will be 120. And the derivative of negative 48 is just 0. So here are my solutions that I'm boxing in: f prime of x, f double prime of x. Okay, so that's some of the way we pronounce it, f double prime. And then this last problem here is just the fourth derivative, or f quadruple prime. But the 4 in the superscript with the parentheses is a more succinct and brief way to state that solution. All right, so that concludes the discussion of higher order derivatives for now. Ask for help whenever you need clarification. Thank you for watching and have a wonderful day.